Hello Internet, Oscar Veliz here, showing you how to find roots using Newton's method. And Newton's method is a really neat algorithm that's a lot faster than bisection, and it's pretty simple too. So let's get started. First off, what is Newton's method? Well, Newton's method says to first pick an x that's close to the root of a function, and then also take the derivative of the function to get f prime, and then plug it into this formula of xn plus 1 is equal to xn minus the function at xn divided by f prime of xn. And please make sure that f prime of xn is not 0, so you don't get a divide by 0 error. Afterwards, you're going to repeat until it converges, where xn is about the same as xn plus 1. Here's a good example, and a graphical representation. So say you want to find the root of the function sine of cosine of e to the x. When you have your function, you'll first pick an x. So let's pick this x and call it x1. And you're going to find the derivative of that point to get the slope. And what it's really giving you is a tangent line of this function at x1. And then you're going to use that line to find your next x, which we'll call x2. And we'll repeat this process until we come up with a root. So now if we take the derivative of the function at x2, we're going to get another tangent line. And this time, where that intersects is close to the root, and we'll keep going until we find something that's acceptable and the function converges. Please note, though, that your point really should be relatively close to the root that you want to find. However, if the point that you get has a slope of 0, then you'll never know where to calculate your next x. Now let's say we want to find a square root using Newton's method. Well, first, we're going to use this function of x squared minus a and find its derivative of 2x. This works because when f of x is 0, then x squared is equal to a, and therefore x is equal to the square root of a. So using Newton's method, we're finding square root without using a square root function. When we plug it into Newton's method, we're going to get that xn plus 1 is equal to xn minus the quantity of xn squared minus a divided by 2 to the xn. Now we can stop here, or we can simplify a little further and come up with this function. But really, the first equation is all you need. Now let's do another example. Let's say your function is x to the 7th minus 1,000. So what this function is really asking us to do, if we want to find the root of it, is find the 7th root of 1,000. Let's say that your TI-89's battery is dead, and you're left to use a 4-function calculator. What do? Use Newton's method. So we'll plug this into the formula for Newton's method and come up with this equation. Let's pick x1 to be 3. Plug this into our equation to find x2, which turns out to be 2.767 something or other. Then we'll take x2 and replace it where we had x1. If we do that, we'll come up with x3, which is 2.69008, and so on and so forth. Repeat the process, we get x4, 2.68. Notice that the numbers don't seem to be changing a whole lot from the previous iteration. This means that it's coming close to converging. If we repeat this process, x5 comes out to be 2.682 and so forth, and then x6 turns out to be 2.682 and so forth. Now notice that x5 and x6 match in about 8 decimal places, and you can use this as your answer. Now let's talk about the order of Newton's method. As you might remember from my bisection video, the order alpha is equal to the natural log of some error division divided by the natural log of another error division. And so all we need is 3 errors to figure out what our order is. So if we are given 3 errors, and we want to find the order, we simply plug those in and come up with an alpha of about 2.003. Now this is saying that the order of Newton's method is quadratic, which is true. However, it isn't always going to converge quadratically for all functions, and Newton's method isn't always guaranteed to converge at all. But if you start close enough to your root, your function should converge. Thanks for watching. Hope you learned something.